All right, team. So this is now looking at the full-blown how to sketch a sine or cos graph with all types of transformations. Notice that example 22 is actually similar to the one I had done before in the previous exercise, the last one here. So I'd recommend that you watch this one first before doing this one. But the example is actually the same. The only difference is they added on the +2. If you have a look at the problem, so let's have a look here. So you notice it's 3 sine 2 and then t minus pi and 4. It's the same thing. So technically the graph, we already know what it looks like. It looks like this. And it moves up by 2. Pretty much like that. But I'm going to do it from scratch. I'm going to pretend that we didn't know how to do this. And if you can see how I do the techniques, then you can apply it to any of these graphs down here. Where's that? 14. Oh, no, sorry, that's not the right one. I need to fix that. All right, let's do this, okay? Let's do it from scratch. Fully imagine that you don't know what this graph looks like, and we're going to sketch it. It says here, use a calculator. Don't. You're going to learn how to do this with quarter cycles, okay? So here we go. Again, amplitude. Amplitude we know is 3. We know that the period is based on this 2 here. So period is usually 2 pi, but that 2 is a dilation factor of half. So it compresses it. Okay, so it now becomes pi. So 1 period takes pi distance. Notice that there is a minus pi and 4. And remember my technique, let it equal to 0. So t minus pi and 4, solve for t. T will equal to pi and 4. So that means it moves to the right by pi and 4. And then this +2 means up by 2. Okay, and the domain, whew, look at that. Domain is between pi on 4 to 5 pi and 4. And really, they've still kept it pretty nice for you because they're moving by pi and 4, yet the distance is still in, the domain is still in pi and 4s. When it gets hard is when you don't have the domain as pi and 4 to pi and 4. It could have been pi and 6 to 7 pi and 6 for all I know. Okay, so this is still technically a nicer example of a full-blown transformation. But let's do this. How do I do this? First thing is find quarter cycles. Okay, if you don't know what quarter cycles is, go back and watch my previous video on example 21 essentially. But quarter cycles, this is pi is your period, so divide by 4. So pi divided by 4 gives me pi on 4. That's my quarter cycle. All right. I'm going to draw my graph. Okay, it's a very quick hypothetical graph. This is not the one I'm actually going to be drawing. It's just to visualize the problem. Okay. We know the amplitude is 3, so normally it's 3 and minus 3, right? So that's my minimum. And this is a sine graph, so normally sine graphs start off at 0. So this is where my starting point is. You always got to find the starting point. And what do we know with the starting point? We know that it starts off 0, 0, and it tells us that we're going to move to the right by pi on 4. So I'm going to move it to the right by pi and 4. So the center is now moved to pi and 4 over here. But then it's also moved up by 2. So 2 is about, I don't know, maybe say here. Make it up. So 2 is here. Technically it's not, but let's just say it's there. Okay? So this is my new starting point. That's what you need to know. Okay? So this is my new starting point. Starting point, SP. Okay? So that's my new starting point. Now, that starting point is the center. Okay, if that's my new center, this is my new center, all right? Remember the amplitude is 3, so if I moved up by 2, that means my maximum now has moved up by 2 as well. So my new maximum is no longer 3, but it has to be at 5. True, so maximum is at 5. I'm gonna do don't do these dotted lines. If it helps you, do the dotted lines, but normally when you sketch, don't keep it in. Do it in Gradle and then rub it out, right? And that also means the minimum, which used to be at -3, now moves up by 2 as well. So now the minimum is at -1. True? So think about it. I've just shifted all up. So hopefully all these dotted lines don't confuse you, but I want you to see that now the numbers are no longer -3 and 3. It is now at -1 to 5 because of the transformation that goes up and down. Okay? So our starting point starts at the center. So don't forget that. Our starting point, I'm just going to rub this one out carefully so that it reminds you the center is here now. That's your center. Okay, ignore that green dot over here. I don't know how to rub it out without rubbing out the axle. Oh, there we go. That's our starting point. Now, the reason why we wanted to know our quarter cycle is because we needed to know starting at pi on 4, okay, so starting at SP is at pi on 4. To get to the next quarter cycle in a sine graph, so remember sine graph, okay, this is the center, that's the starting point. To get to the next quarter cycle will bring you to maximum. The next quarter cycle brings the center to the minimum, to the center, to the maximum, to the minimum, center, to the minimum, to center, max. Okay, that's the pattern. So we've got our first point. We're starting here. So if we can find out how long it takes to get to the maximum, we can then follow the pattern. So pi on 4, that's my starting point. I'm adding on the quarter cycle. So the quarter cycle was also pi on 4. And that's what I'm saying, it's making it nice and pretty easy for you there. So next quarter cycle, I only need to add another pi on 4. So that makes it now 2 pi on 4 to get to the maximum. So maximum, okay? Then to get to the next quarter cycle, which brings it to the center, it is now 3 pi on 4. Then to get to the minimum, it is now another pi on 4. So now it gets to 4 pi on 4. And then to the next one is 5 pi on 4. The next one is 6 pi on 4. And the next one is 7 pi on 4. And you can do this on and on and on forever. But remember, the domain was only from pi on 4 to 5 pi on 4. So that means I can stop at this point here. So answering the question, I know that it went from center, maximum, center, minimum, center. And that's pretty much it. So this is my shape. This is what my graph should look like. Can you see that? I now happen to... I can't seem to sketch this properly. There we go. So I've got my nice sine graph there. And if I just rub out these dotted lines just to help you see. So rub this out and do that. Rub this one out so it's a nice line so you can see. This is what my graph should look like, technically. But what have I not got that is perfect is the x-intercepts. Now I don't know what the new x-intercepts are. See that? These are my new x-intercepts. That's why in 14J you have to do an extra step now after your quarter cycles and all that. Now you know you need to find... Sorry, I'm going to write there 2 pi on 2 pi 4. Now you know you need to find x-intercepts. And you can clearly see in your graph there you should only have 2. Okay? So if you get more than 2, you know you've done something wrong. So here we go. We're going to do... y equals to 3 times sine of 2, or I should put the 2 on the outside. Sine of 2 t minus pi and 4 all over plus 2. And this is where the challenge is. How do you find the x-intercepts, right? And remember, to find x-intercept, let y equal to 0 to find x-intercepts. That's what you've always been doing since, I guess, year 9, essentially, to find x-intercepts, or year 8, really. So you are trying to solve this equation. 0 equals to 3 times sine of 2 times t minus pi on 4 plus 2. And this is where a lot of students will struggle. Okay, and this is why the previous exercise, I put a lot of emphasis that you need to know how to do this. Okay, so I'm going to... Oh, actually, they didn't even want you to find this. Sorry, you can't actually do this by hand. You have to use a CAS, because when you solve it, it's negative 2 equals to 3 sine of 2 times t minus pi. They didn't give you ones with nice exact values, so negative 2 and 3, we don't know that. Sine of 2t minus pi 4. So maybe I'll just stop here and I'll make a different video. But you can see, when you do sine inverse on both sides, we don't know what exact value will give you a negative 2 and 3. That's not part of it. Okay, but if you had gotten up to this step here, watching my previous videos on how to solve this, you change the domain, and then whatever this is, you work with a unit circle, same thing again, but I don't want to confuse you right now. So let's just ignore that, and it just means that you do have to use a calculator to find the x-intercepts there. Okay, so I'm probably going to make a different video where I'm going to find an example where you can do exact values, and it's probably likely this one. Okay, so I'm going to do a video of that one, but I guess I should have listened to the question, and they told us to do use a calculator to establish the shapes. Well, I didn't use a calculator to establish the shape. I got the shape. I just don't have the x-intercepts, and you can do that on your CAS. So we go to our CAS. I'm just going to clear all that. You're going to do menu, press the number 3, so for algebra, press number 1 for solve, and you're trying to solve 3 times sine of 2 times t, or x minus pi on 4. So pi on 4, here we go, pi over 4, close brackets plus 2. And you're trying to solve for comma x, and now you got to put in the domain. So here we go, comma. I realize I haven't given an equation. So 0, x is between 0, not 0 actually, it was negative pi, oh no, pi and 4 to 5 pi and 4. Woo, what a nasty fraction to work with here. So it's a bit harder with a mouse here. So x, and this one should be, oh no. No. All right, I'm going to put the fraction in. Oh. 0. Oh. I need to do a given. Sorry, I forgot to do given. Given that it is between pi on 4 to 5 pi on 4, wasn't it? 5 pi on 4, delete the x. And don't forget, it was meant to equal to 0 because I'm solving for the x-intercept. So let's see if I've typed everything right. It's all in radian mode. Good. Then I get my answer in exact value. But then it shouldn't be exact value, but no, it doesn't look good. Okay, so we're going to change that. Control Enter will give you the decimal point. So that's what I'm saying. We couldn't have done the exact values. It was too hard. So there you go. Those are your 2 x-intercept points. So we now know that the x-intercept here was 2 point... I should just copy it so that it makes it easy to see. So here we go. We're going to copy that. And I'm just going to paste it. Come on. Control V. And we're just going to move this over here to see what I did. Okay, so I now know, solving this part here to find the x-intercepts, I now know that the x-intercepts that you have, this one over here is 2.721 when the y value is 0, and the other one clearly is then 3.562 when the y value is 0. Okay, so that's your 2 x-intercepts that you essentially have. This one goes here, and then this one goes here. All right, but that's why you couldn't have done that by hand, because we don't know the exact values for that, and you do actually have to use a calculator. But there you go. That's essentially what you would be doing in this exercise. I will make a separate video for example 23, so you can see how I do it from scratch, where you have to find the x-intercepts by hand. You have to use the quarter cycles to sketch the graph neatly, and that's it. There you go.